So isopropyl chloride undergoes hydrolysis by which mechanism? SN1, SN2, SN1 and SN2, or either SN1 or SN2. So isopropyl chloride. This is isopropyl chloride. And here chlorine atom linked with the secondary carbon. Okay. So you know that for SN1 reactions, order of reactivity is tertiary alkyl halide is greater than secondary, secondary is greater than primary. For SN2, that is primary is greater than secondary, secondary is greater than tertiary. So here nature of the carbon atom is secondary carbon atom. Okay. So that's why in isopropyl chloride, so we observe either SN1 mechanism or SN2 mechanism. So option D is correct. SN1 mechanism or SN2 mechanism. Next, tertiary alkyl halides are practically inert to substitution by SN2 mechanism because of. So here type of mechanism is SN2. So generally SN2 mechanism more favorable is primary alkyl halides. So what are primary alkyl halides? Alkyl halides in which halogen atom linked with the primary carbon. What is primary carbon? Carbon linked with a single carbon. Okay. Secondary carbon is carbon linked with two other carbon atoms. Tertiary carbon is carbon linked with three other carbon atoms. Okay. So tertiary carbon undergoes steric hindrance. Steric hindrance means it is surrounded by bulk groups. So three methyl groups are present around tertiary carbon. Okay. So this leads to steric hindrance. Okay. And carbon linked with halogen atom here. So for tertiary carbon, chlorine atom or bromine atom, that is linked in tertiary alkyl halides. Okay. So due to steric hindrance, tertiary alkyl halides, they are inert to SN2 mechanism. Okay. But tertiary alkyl halides, they are more favorable to SN1 mechanism. So where we observe reaction mechanism takes place through the formation of carbocation intermediate. Okay. But in case of SN2 mechanism, these are quite inert in nature. Why? Because steric hindrance is there. Tertiary carbon atom that is surrounded by more number of alkyl groups. So steric hindrance. Okay. Next. Which of the following will be the least reactive towards nucleophilic substitution reactions? So here different halides are there. Aromatic and aliphatic. Okay. So first coming to C2H5Cl. So in ethyl chloride, chlorine gets linked with the sp3 hybrid carbon. So it is more favorable towards the SN1 reaction. So more reactive towards the nucleophilic substitution reactions. Okay. Then here cyclohexane and it is linked with halogen atom. So in cyclohexane also, here carbon atom that undergoes sp3 hybridization. So that's why it is also more reactive towards nucleophilic substitution reaction. Okay. And here this is benzyl chloride. So chlorine halogen that is linked with sp3 hybrid carbon only. Okay. It is linked to the side substitution of the benzene ring, not directly to the benzene ring. Okay. So that's why here due to linkage with sp3 hybrid carbon, this compound also more reactive towards SN1 reaction. And coming to this, here halogen atom directly linked with sp2 hybrid carbon. Okay. So in resonating structures, it attains some partial double bonding in between carbon and chlorine. Okay. So due to this, much energy required for the breakage of that bond. So that's why this compound is least reactive towards the nucleophilic substitution reactions. Okay. So option D is correct. Okay. This is the compound which is less reactive towards nucleophilic substitution reactions. Next. Which of the following halides would undergo SN1 reaction more readily? Okay. Substitution nucleophilic reactions. So here 1-chloro, 1-butene. So here but 4 carbons. At the first carbon only unsaturation is there. And first carbon is linked with the chlorine. 1-chloro, 1-butene. Okay. And here this is primary carbon. Okay. Then 2-chloro, 1-butene. 2-chloro, 1-butene. So unsaturation is at first carbon and halogen atom is linked to second carbon, which is sp2 hybridized carbon. Okay. Next, 3-chloro, 1-butene. 3-chloro, 1-butene. Okay. So here unsaturation is present at first carbon and this is secondary carbon. Carbon here is secondary carbon. Okay. And type of hybridization here is sp3 hybridization. And halogen atom linked to the secondary carbon. Okay. So that's why here this is the compound which more readily undergoes SN1 reaction. And you may check fourth option also. So what is this? 4-chloro, 1-butene. So 4-chloro, 1-butene. So unsaturation is present at first carbon and chlorine is at another end. Okay. And this is also primary carbon. Okay. But SN1 reaction more favorable is tertiary followed by secondary, secondary followed by primary. But here no tertiary is there, secondary. So this is the compound. So